So remember from our last video, we had the following conjecture. We had that A cross C intersect B cross D is equal to A intersect B cross C intersect D. So we're going to start. Remember, you're showing two sets are equal, so you need to show that each one is a subset of the other. So there's two parts to our proof. Part one, I'm going to show A cross C intersect B cross D is a subset of A intersect B cross C intersect D. So again, we're going to start with our outline of our proof. What would the start be? I'm going to start with something in this intersection, but it's in a Cartesian product, so I'm going to start with xy being in A cross C intersect B cross D. And then what's the end of my proof going to be? That this element is in the other side. So the end will be that xy is in A intersect B cross C intersect D. So this means x is in A intersect B and y is in C intersect D. So that's what I need to get to. So going forward, if it's in an intersection, that means it needs to be in both sets. So it needs to be in A cross C and in B cross D. So because xy is in A cross C, I know that x is in A and x is in C because it's in, and y is in C. Because it's in B cross D, I know x is in B and y is in D. So what do I have so far? I have that x is in A and x is in B. That means that x is in A intersect B, y is in C, and y is in D. So y is in C intersect D. And that's exactly what I needed to get to. I needed that x is in A intersect B and y is in C intersect D. So I'm done now with my outline, and we can write our formal proof now. So again, reference your outline when you're writing your formal proof. Let xy be in A cross C intersect B cross D. Then xy is in A cross C and xy is in B cross D. Since xy is in A cross C, x is in A and y is in C. Since xy is in B cross D, x is in B and y is in D. And I'm going to say since x is in A and x is in B, x is in A intersect B. Since y is in C and y is in D, y is in C intersect D. So since x is in A intersect B and y is in C intersect D, xy is in A intersect B cross C intersect D. Therefore, A cross C, what we've proven says that A cross C intersect B cross D is a subset of A intersect B cross C intersect D. So we've completed part 1 of the proof. Now we need to do part 2 of the proof, which will be in the next video.